So good morning everybody. Myself आचार्य विश्वेंद्र आज बॉक्स मॉडल पे एक क्वेश्चन आंसर सेशन पे डिस्कशन करूंगा आपसे. आइए स्टार्ट करते हैं. So here is a discussion on Bohr's atomic model. The first question is it was proposed by the Danish physicist Niels Bohr. Second question is it was proposed in the year. So it was proposed in the year 1913, which is official data as per the model is concerned. Next is number of postulates. So there were 3 postulates in it. First postulate is related to the stationary states, which states that electron moves only in certain orbits or fixed energy states without radiating energy. So these states are called stationary states. In stationary states, electron is not stationary. In fact, the energy of the electron which is moving in a certain orbit is stationary as it does not radiate any energy, which explains the stability of atoms well. Now is the second postulate. So second postulate is about angular momentum, and it says that electron moves in certain orbits with quantized angular momentum given by nh upon 2 pi, where n is the energy state of that particular electron. So this was the second postulate. Third postulate was regarding the transition. When electron makes a transition from one of the state to another state, let's say from E1 to E2. So it will make a transition from one state to another state by emitting or absorbing in the reverse case a photon of a specific frequency and energy. And energy of that photon is equal to the energy difference between the two states. So here I can say that E is equals to mod of E1 minus E2, which is equals to He2. So which is the third postulate of Bohr. For this limitation, so there were certain limitations. The first is it is applicable only for single electronic species, single electronic or hydrogen-like species. And the second was it was unable to explain relative intensity of line spectra. Relative intensity of line spectra. As you might be knowing that hydrogen, if we observe the emission spectra, it's comprising of 7 certain lines, Lyman, Balmer, Paschen, Beckett, and Pfeffer. So that is easily explained by Bohr that the emission will be a line spectra as frequency of the photon is quantized, it's not continuous. So that is well explained. But the second postulate that the relative intensity. For example, if you undergo, you study the emission spectra of hydrogen atom, let's say comprising of about 100 atoms and 100 electrons are, we assume that all are making transitions. Then out of those 100 transitions, the lower energy transitions, that is after, Paschen, Beckett and Pfeffer, the lower energy transitions are more preferred. Or we can say that some transitions are preferred over other transitions. So it was not explained as per the Bohr's model postulate. So these were the two limitations. Next to now there are certain parameters of electrons. So the first is radius in nth state. So it is equals to R naught n square by z, where n is the energy state and z is the atomic number. R naught here is 0.529 angstrom. Now speed of electron in nth state is V naught into z by n, where V naught is 2.189 into 10 to the power 6 meter per second, which is also called C divided by 137. C is the speed of light. So this is how we can find speed of electron in nth orbit. Next question is angular momentum of electron in nth orbit. It is equal to nh by 2 pi, where n is the energy state, h is the Planck's constant. So this is how you can find that. And one more important thing is dimensions of angular momentum and Planck's constant are same. This question has been asked many times in me, so this is your pen. Next is time period. So time period of electron in nth orbit is t naught n cube by z square, where t naught is 1.52 into 10 to the power minus 16 seconds. it is about 1.5 into 10 to the power minus 16 second. So the relation follows that it is proportional to n cube and inversely proportional to the square of atomic number. Now is the frequencies of frequency is 1 by T naught, and if we solve it comes out to be F naught Z square by n cube. So F naught here is 6.25 into 10 raised to the power 15 hertz. So this is approximately equal to this. So it's standard effect, and the frequency of electron in nth state is given by this. Then we have kinetic energy of electron in nth state. So the kinetic energy is 13.6 electron volt Z square by h. And if you want to convert it into joule, you can simply do that by multiplying with 10 raised to the power 1.6 into 10 raised to the power minus 19 Z square by n square. This will be in joule. So this is how you can do. Potential energy is minus twice of kinetic energy. So it is minus 27.2 electron volt Z square by n square, or equivalently minus 27.2 into 1.6 10 raised to the power minus 19 joule Z square by n square. Then is total energy, it is equal to minus of kinetic energy, which will be 13.6 Z square by n square electron volt, or equivalently 13.6 into 1.6 10 raised to the power minus 19 Z square by n square in joule. So this is how you can calculate things. Let's solve a question. Electron makes a transition from energy state E1 to E2. Total energy of electron in first state. So as we have done over here that it is minus 13.6. N here will be N1 square. This will be unit we take as electron volt. Second question is energy of electron in the second state. So here energy state will be N2. So we can write it as minus 13.6 N2 square. This will be electron volt. Next question is energy difference. So we take the difference as E1 minus E2. So we'll get 13.6. The terms will be replaced 1 by N2 square minus 1 by N1 square, taking 13.6 as common. So this is the energy. Then the next question is frequency. So we can say that frequency is equals to energy difference divided by h. So that will be 13.6 electron volt upon h, and this will be 1 by N2 square minus 1 by N1 square. Then is 1 by lambda. So we can say that lambda is equals to c by frequency. So it will be nu by c. So nu by c will be 13.6 by hc electron volt 1 by N2 square minus 1 by N1 square. So from here if we calculate lambda, so that will be 1 upon this thing. So 1 upon 13.6 electron volt hc will come over here, and here it will be 1 by N2 square minus 1 by N1 square. So this is how we can calculate lambda. It's a simple manipulation. Now there is a question based on lithium plus 2 atom having atomic number 3. We need to find radius of the third orbit. So radius is r naught n square by z. R naught here will be 0.529 angstrom. N is 3. So 3 square, z is also 3. So that will be 3 into 0.529 angstrom, and we get that's 1.587 angstrom approximately. Then next question is speed of electron in the second energy state. So this we can say is that this will be 2.18 into 10 raised to the power 6 z by n. So z and n both are same, so that will be 2.18 into 10 raised to the power 6 meter per second, or approximately c1. Then is time period of electron in fourth state. So we know that time period is t naught n cube by z square. So t naught here is about 1.5, 1 into 10 raised to the power minus 16, and it was 5 2. And here this is 3 cube, this is your 3 square, so this will be 3 times, so that is 4.56 into 10 raised to the power minus 16 second. Next question is angular momentum in third state. So we know that angular momentum is given by nh by 2 pi. So that will be 3h by 2 pi. Or we know that h is 6.6 10 raised to the power minus 34